Good morning, all of you. In our inorganic chemistry, today's topic is the oxidation state and the inert pair effect. In the last lecture, we have studied the metallic characters, how the metallic character affected the p block elements. Now, the oxidation state and the inert pair effect. P block element generally shows the lower oxidation state. P block element generally shows the lower oxidation state. This lower oxidation state decide on the basis of the number of electron pair participating in the bonding and the energy required to unpair the electrons. S electrons pair exceed the energy evolved during the bond formations. So this lower oxidation state decide on the basis of electron pair participating in the bondings and the energy required to unpair the S electrons pair exceed the energy evolved during the bond formations. Therefore, the ns electron remains paired, and this property of the ns electron from the taking part in the bonding is called as inert paired effect. Because we know that the valential electronic configurations of p block elements of all the elements of the boron family having the electronic configuration is ns2 and np1s. In this case, only np1 electrons takes part in the bond formations. ns2 electron remains unreacted, means the electrons remain paired. This property of ns electron pair from taking part in the bonding is called as inert pair effect. If only np1 electrons, if only np1 electron takes part in the bonding, the oxidation state is +1. If all three electrons, that is ns2 and nsp, takes part in the bonding, the oxidation state is +3. Hence, the boron family shows the +1 and +3 oxidation state. However, for showing the +3 oxidation state, energy required is very high. Hence, tendency to form the boron family shows the +1 and +3 oxidation state. However, from the showing the +3 oxidation state, energy required is very high. Why it is energy required very high? Because energy required to unpaired electrons, that is ns2 electrons, is very high. Because in the ns electrons are in the very compact states, it cannot be easily unpaired, so it required a very high amount of energy. Hence, the tendency to form the trivalent cation is less. The stability of the +3 oxidation state decreases, and that of the +1 oxidation state increases from aluminum to thulium due to inert pair effect. That of the +1 oxidation state increases from aluminum to thulium. This is all about that. This is a very important sentence, that the stability of the +3 oxidation state decreases and that of the +1 oxidation state increases from aluminum to thulium due to the inert pair effect. Okay, means the starting at the aluminum there is a +3 oxidation state, but as we goes from aluminum to thulium, point arrives from where the +1 oxidation state is more stable due to the inert pair effect. Next point is the melting and boiling points. Group 13 elements does not show the regular trend in the element of the other groups. in the melting and the boiling points. Melting and boiling point depends on the crystal structure. Melting and the boiling point depends on the crystal structure shown by the boron or gallium. Aluminium, indium, thulium have the close packed metallic structure. Therefore, their melting point decreases from aluminum to indium and increases from the thuliums.